All right, good afternoon. This hearing will come to order. Without objection, the chair is authorized to declare recess at any time. Good afternoon. Welcome to today's hearing entitled Water and Geothermal Power, Unearthing the Next Wave of Energy Innovation. Thank you to this distinguished panel of witnesses for joining us. Today we'll be holding another hearing on clean energy technology research and development. I believe this will be our 8th hearing this subcommittee in the 116th Congress to help us focus our scientific research priorities, create major new job opportunities, and address and mitigate the impacts of climate change. Today's hearing focuses on 2 draft bills that would support critical research activity to provide cleaner energy by using geothermal energy and water power technologies. The Earth contains vast amounts of heat just under its surface, which can be tapped and turned into electricity. Today, just 0.4% of total U.S. utility-scale electricity generation is produced by geothermal power plants. But the Department of Energy Geothermal Technologies Office has programs focused on conventional geothermal energy production from hydrothermal resources such as geysers, as well as research focused on enhanced geothermal systems research, which could help us access the higher temperatures deeper underground. This has the potential to increase geothermal electric power generation to 60 gigawatts of installed capacity by 2050, up by about 4 gigawatts today. This potential is why it's important for us to focus on R&D in this promising area. The draft Geothermal Energy Research and Development Act of 2019 would reauthorize the activities of the DOE Geothermal Technologies Office. In addition to laying out focus areas for both conventional and enhanced geothermal systems, this legislation would instruct the Secretary to establish a demonstration initiative for advanced geothermal energy systems. And we have heard from many witnesses in many areas all year about the importance of doing not only the fundamental research, but also the demonstration scale research for these technologies. And we'll be looking to hear from you all about that today as well. At least one of the demonstration projects in this initiative must be located in the eastern United States, which currently has no such facility. And finally, the bill would authorize 2 frontier Observatory for Research in Geothermal Energy, or FORGE, sites, including the site DOE selected in Milford, Utah. Today we will hear from Dr. Joseph Moore, who is the project manager at that site. Another clean energy technology we will be discussing today is water power, which includes conventional hydro, pump storage, and marine energy technologies. Around 7% of total U.S. utility-scale electricity generation is produced by conventional hydropower. Pairing this technology with pump storage systems allows energy produced by hydropower plants to be deployed to the grid flexibly. Marine energy, which includes wave, tidal, and current power, is another water power technology that has great potential. DOE's Powering the Blue Economy initiative highlights the importance of each maritime industry to the success of other such industries. Investing in this technology can help improve other areas of coastal and maritime markets, such as underwater vehicle charging and aquaculture. Given the overlap and independence between these industries, it makes sense to address the blue economy as a whole. The Water Power Technologies Office at DOE can do just that and support research across a wide range of technologies. So the draft Water Power Research and Development Act of 2019 emphasizes key R&D focus areas and supports, again, important technology demonstration activities. It also authorizes existing and new national marine energy centers, which are testing sites for marine energy technologies hosted by academic institutions and funded by both government and private industry. We are lucky today to have Dr. Bryson Robertson, co-director of the Pacific Marine Energy Center, to tell us about the important research done at these centers. I want to thank our panel of witnesses for coming all the way here today, and I look forward to hearing your input and feedback on these important topics, and especially on our draft pieces of legislation. The chair now recognizes the ranking member, Mr. Weber, for an opening statement.
Thank you, Chairman Lamb, for holding today's subcommittee hearing. Looking forward also to hearing from our witnesses about the state of water and geothermal power technologies in the U.S. and about the Department of Energy's innovative clean energy R&D activities in these areas. Water and geothermal power R&D is funded through the Department's Office of Energy Efficiency and Renewable Energy, or EERE. And as we discuss yet another applied energy program this afternoon, it is important to remind ourselves that EERE is by far the Department of Energy's largest applied research program. At almost $2.4 billion with a B dollars in annual funding, EERE receives more funding than the R&D budgets for research in fossil energy, in nuclear energy, electricity, and cybersecurity combined. Since DOE's Water Power Technologies Office, WPTO, and Geothermal Technologies Office, GTO, are both housed under this very well-funded program, I'm kind of again surprised to see my colleagues on the other side of this aisle propose legislation to grow these offices even more without proposing the funding offsets. As written, the Water Power Research and Development Act would increase spending on EERE's water power technologies activities by nearly 60% by fiscal year 2024. Similarly, the Geothermal Energy Research and Development Act would increase annual spending on EERE's geothermal technology activities to $150 million with an M dollars, which is nearly 70% higher than the House-passed 2020 appropriations level. It would also provide $150 million for this program each year through 2024. Once again, I do want to be clear, I'm supportive of DOE funding for innovative research in advanced renewable energy sources. And I believe that these technologies play a vital role in our country's path forward to a clean energy future. This is why I'm also supportive of basic research, the kind that the energy industry cannot conduct, like research in advanced computing, machine learning, and the development of new materials. This discovery science lays the foundation for the next technology breakthrough and can only be supported by the federal government. This will require sustained federal investment in the construction of critical research facilities and infrastructure across the country, particularly in our world-leading national laboratories and in our universities. By providing American researchers with the tools to perform that cutting-edge research, we can accelerate the development of a diversity of advanced energy technologies. These are the kind of investments we see prioritized in my friend Ranking Member Lucas's bill, the Advanced Geothermal Research and Technology Act of 2019. I'm also particularly pleased to see investments in a geothermal advanced computing and data science program and critical support for GTO's innovative experimental user facility included in this legislation. Best of all, it prioritizes these areas responsibly without significant increases in new spending. So I'm looking forward to considering this bill, Mr. Chairman, and hearing about the research it would prioritize today. So in closing, I feel like I keep repeating myself. I hope that moving forward, we can focus on prioritizing investments in fundamental research that we all agree are necessary to develop new energy technologies. And with that, Mr. Chairman, thank you again for holding the hearing. I yield back.
Okay, at this time, I'd like to introduce our witnesses. Dr. David Solan is the Deputy Assistant Secretary for Renewable Power in the Office of Energy Efficiency and Renewable Energy at the U.S. Department of Energy. He directs renewable energy applied research, development, and demonstration activities for the geothermal, solar energy, wind, and water power technology offices at EERE. He also oversees EERE's energy system integration efforts. Previously, he was the acting executive director and principal deputy director of the Office of Policy, as well as a senior advisor in the Office of Science. Welcome, Doctor. Dr. Bryson Robertson is the co-director of the Pacific Marine Energy Center and an associate professor in civil engineering at Oregon State University. He has a Bachelor of Mechanical Engineering from the University of Victoria and a PhD in environmental engineering from the University of Guelph. He has spent the better portion of the past 20 years actively involved within the North American marine energy market, energy systems, and coastal energy engineering sectors. Dr. Joseph Moore is the manager of the Utah Frontier Observatory for Research in Geothermal Energy, or FORGE. He also holds appointments at the University of Utah as a research professor in the Department of Civil and Environmental Engineering and as an adjunct professor in the Department of Geology and Geophysics. His expertise is in the geology, hydrothermal alteration, and geochemistry of geothermal systems, and his current research is focused on expanding geothermal development through the creation of enhanced geothermal systems. Ms. Maria Richards is the director of the Geothermal Laboratory in the Roy Huffington Department of Earth Sciences at Southern Methodist University. She was the president of the Geothermal Resources Council in 2018. Her current research focuses on the use of temperature well logs for understanding climate change, the transition of oil fields into geothermal production, and low-temperature geothermal applications such as district heating for commercial buildings. Mr. Sander Cohan directs North American innovation for Enel, Green Power North America, Inc. He has over 15 years of experience in the energy sector, specializing in innovation and emerging and alternative energy technologies. He has served as Chief Project Director and Manager for technology projects in diverse areas, such as energy, storage, microgrids, and smart grid technology, predictive analytics, geothermal energy, hybrid renewables, and marine energy. Again, I know many of you came from far away today to be with us, so we really appreciate that. As you know, you will have 5 minutes for your spoken testimony. Your written testimony will be included in the record. When you've all completed your spoken testimony, we will begin with questions. Each member will have 5 minutes to question the panel. We will start with Dr. David Solan.
Thank you. Chairman Lamb, Ranking Member Weber, and members of the Energy Subcommittee, thank you for inviting me to testify today on the opportunities and challenges of geothermal and water power technologies and the activities that the U.S. Department of Energy is undertaking to help secure America's future through energy independence and scientific innovation. My name is David Solan, and I am the Deputy Assistant Secretary for Renewable Power in the Office of Energy Efficiency and Renewable Energy, or EERE. I direct renewable energy applied research, development, and demonstration activities there. Today, I will be discussing the valuable work underway in two of our technology offices, the Geothermal Technologies Office, or GTO, and the Water Power Technologies Office, WPTO. I will also highlight several announced and upcoming activities at the department. GTO conducts R&D to reduce costs and risks associated with geothermal development by supporting innovative technologies that address key exploration and deployment barriers. The U.S. is the world leader in installed geothermal capacity. As an always-on energy source that harnesses the Earth's natural heat, geothermal energy provides baseload power with the flexibility to ramp on and off. Geothermal power plants can also provide essential grid services and operate in a load-following mode, helping to support reliability and flexibility in the U.S. grid and ultimately facilitating a diverse, secure, and resilient energy mix. Geothermal energy can be used in three technology areas. The first, generating electricity. The second, providing residential and commercial heating and cooling using geothermal heat pumps. And the third, direct use applications that can provide district-scale heating solutions, as well as a wide array of commercial and industrial applications where process heat is required. In May 2019, the department released its GeoVision analysis, a multi-year collaboration among DOE and its stakeholders to evaluate the potential for different geothermal resources. It assessed opportunities to expand U.S. geothermal energy deployment through 2050 by improving technologies, reducing costs, and addressing project development barriers such as long permitting timelines. GTO's flagship initiative, the Frontier Observatory for Research in Geothermal Energy, known as FORGE, heads the list of activities called out in the GeoVision roadmap. FORGE is a dedicated site to develop, test, and accelerate breakthroughs in enhanced geothermal systems, technologies, and techniques. It is now finishing the second of three phases, with the third slated to start later this fall. Turning to WPTO, it works with national laboratories, industry, universities, and other federal agencies to conduct R&D activities through competitively selected projects. It is pioneering efforts in both marine energy and hydropower technologies to improve performance, lower cost, and ultimately support our ability to meet evolving energy demands. Hydroelectric power is the leading renewable energy source in the U.S., accounting for 7% of utility-scale electric generation in 2018. Conventional and pump storage hydropower are stable power sources that are also flexible enough to smooth out fluctuations between electric generation and demand, as they have large reservoirs of fuel, that is water, to fill any gaps in generation at a moment's notice. This stability and flexibility supports the deployment and integration of more variable renewable resources, such as wind and solar. Hydropower and pump storage fit in extremely well with the department's activities in the Grid Modernization Initiative, or the GMI, Just last week, we announced $80 billion for new laboratory call projects. This is the latest solicitation released by the GMI, a cross-cutting DOE effort to develop new tools and technologies that measure, analyze, predict, protect, and control the grid of the future. In addition to critical R&D efforts in hydroelectric power, WPTO leads the way in evaluating new sources of marine and hydrokinetic energy, such as predictable waves, currents, tides, and ocean thermal resources. WPTO is investing in this new and innovative industry, a nascent technology sector that can contribute to our nation's energy independence, and which is highlighted in WPTO's report on Powering the Blue Economy, published earlier this year. In addition, as we speak, EERE's Assistant Secretary, Daniel Simmons, is participating at the White House Summit on partnerships in ocean science and technology. Later this afternoon, or as we speak, he will announce exciting developments in 2 new water technology prizes. Thank you for the opportunity to testify before the subcommittee today. DOE appreciates the ongoing bipartisan efforts to address our nation's energy challenges and looks forward to working with the committee on the bills in the future. I would be happy to answer your questions.
Thank you. Dr. Robertson?
Chairman Lamb and Ranking Member Weber, thank you for the opportunity to testify today. In my testimony, I'll address 3 things. First, the domestic marine energy opportunity. Second, the strategic importance of investment and innovation to spur a domestic marine energy technology sector. And finally, the importance of the Water Power Research and Development Act of 2019 for realizing the marine sector's potential. First, what is the marine energy opportunity? It encompasses energy in waves, tides, currents, rivers, salinity, and temperature differentials. Recent resource assessments quantify the U.S. wave resource at approximately 3,500 terawatt-hours, the tidal resource at 450 terawatt-hours, the ocean current is an additional 200, and the river at an additional 150, providing a cumulative total of 4,300 terawatt-hours. To provide perspective, the current U.S. electricity demand is 41 terawatt-hours, so less than the total resource. As such, the marine energy has the as yet untapped potential to provide significant and needed renewable electricity resources to the U.S. grid. These resources would enhance a suite of renewable resources currently helping drive the U.S. transition from fossil fuels to renewable electricity generation. Of further economic interest to the U.S., marine energy offers a number of competitive advantages and opportunities within the emerging blue economy. According to the OECD's 26 report, blue economy-related industries and activities contribute more than $1.5 trillion in value added to the economy each year, and that value is expected to double by 2030. Marine energy is both part of this new economy and plays a linchpin role in providing the necessary power for innovation in the remaining spaces. To this end, the U.S. Department of Energy's Water Power Technology Office recently released its Powering the Blue Economy initiative, which details specific near-term opportunities for marine energy. These include powering oceanographic measurement devices, recharging underwater autonomous vehicles, renewably powering offshore aquaculture facilities, desalinating water, and powering remote isolated communities. It is important to understand and underscore that a principal challenge in achieving the marine energy resource potential is the inconvenient fact that the technology commercialization pathway takes longer and costs more than terrestrial counterparts. That said, for the U.S. to capture the benefits of the marine energy resources, the level of federal investment in early-stage marine energy technology and innovation must at least increase in line with comparative technology investments in our other renewable resources. Water power investment, including marine energy and hydropower, has consistently been 3 to 4 times lower than solar. This is despite the early stage of marine energy technologies and the widely acknowledged importance of federal investment at this stage of innovation to spur economic development. Thanks to the efforts of Congress over the past several years, the U.S. is starting to make significant and strategic investments in the Department of Energy's Water Power Technology Office to support research, development, and the commercial viability of a domestic marine energy sector. Looking forward, the Water Power Research and Development Act of 2019 is essential to providing the strategic direction and authorizing the sustained funding necessary to accelerate the development of a domestic marine energy industry. Unlike wind and solar, marine energy technology developers do not currently benefit from any tax support mechanisms, such as the investment tax credit or the production tax credit. Funding from the DOE WPTO is the key and only mechanism to support U.S. technology developers competing against overseas companies that receive a suite of subsidies. Finally, as a faculty member at an institution of higher education, I wish to close with a focus on the urgent need to educate and train the next generation of energy leaders and maritime innovators. As the world becomes increasingly interconnected and resource-stressed, it is the important role of universities, colleges, and training programs to develop the talent base and workforce who understand the technological, environmental, and social codependencies needed for true innovation. This workforce is required now. It is my hope that the Water Power Research and Development Act of 2019 will provide the fundamental building blocks to ensure that we are able to create this next generation workforce. I thank the subcommittee for your efforts to consider the opportunities associated with the thriving marine energy industry in the U.S., and with that, I'm happy to answer questions.
Thank you. Dr. Moore.
Good afternoon, Chairman Lamb, Ranking Member Weber, and distinguished members of the subcommittee. My name is Joseph Moore, and I represent the University of Utah's Energy and Geoscience Institute. I'm honored to appear before you today to discuss Project Forge, an innovative geothermal energy research project funded by the Department of Energy in the state of Utah. The thermal energy beneath our feet is enormous. Some of this energy reaches the surface naturally through hot springs, like those found in Virginia, Arkansas, and Wyoming. But this is only a tiny fraction of the available energy. If we could capture even 2% of the thermal energy at depths between 2 and 6 miles, we would have more than 2,000 times the yearly amount of energy used in the U.S. Natural geothermal systems require a source of heat, water to transfer the heat, and permeability to allow the water to carry the heat upward. Although we can drill deep enough to reach temperatures suitable for electric generation anywhere in the world and inject water to transfer the heat, most areas don't have sufficient natural permeability to circulate water at the depths we require. Attempts to create enhanced or engineered geothermal systems were initiated by the Los Alamos National Laboratory in the late 1970s. More than a dozen attempts to create reservoirs by hydraulic stimulation followed worldwide, but none created commercial-scale reservoirs capable of producing more than a couple of megawatts of electricity. The Frontier Observatory for Research in Geothermal Energy, or FORGE, was envisioned to be an underground field laboratory where new technologies for enhanced geothermal system reservoir creation and operation could be developed. The Utah Forge site was one of 5 locations in Utah, Idaho, Nevada, Oregon, and California, originally considered for the laboratory. The granite rocks at the Utah site are representative of the geologic environments at many locations across the U.S. Thus, reservoir creation in Utah can provide a template for enhanced geothermal system development elsewhere. The site is located on state land near 3 conventional geothermal plants, a wind farm, a solar field, and a biogas facility. Can you think of a better place to create an enhanced geothermal system? I can't. DOE has obligated nearly $125 million to Utah Forge for FY 2020 to 2024. 50% of the funds will be utilized for research. The remainder will be used for field operations and drilling. The technologies that will be developed are not limited to enhanced geothermal systems. New stimulation and drilling technologies will also improve the productivity in conventional geothermal systems and high-temperature oil and gas plays by reducing the number of wells that must be drilled. In 2020, we will begin full deployment of the Utah Forge Laboratory. The centerpiece of the laboratory will be a pair of deep wells into rock with temperatures of 400 to 450 degrees Fahrenheit. One of the wells will be for injection, the other for production. The second well will be completed in FY 2023. Testing and demonstrated commerciality of enhanced geothermal systems will occur in the following 18 months. At the end of 2024, Utah Forge will decommission the site, plug and abandon the wells, and bring the drill pads back to their original grade. The Utah Forge site is a unique, publicly owned and operated laboratory and an essential stepping stone to commercial enhanced geothermal system development. Maintenance of the site beyond 2024 will provide a facility where new technologies can be tested at low cost in an ideal enhanced geothermal system environment. No alternative facilities currently exist in the U.S., and none are envisioned at this time. We strongly urge the committee members to continue their support of Utah Forge and enhance geothermal system development in the U.S. Thank you for the opportunity to testify on Project Forge. I am happy to answer any questions you may have.
Thank you. Ms. Richards.
Chairman Lamb, Ranking Member Wimber, and members of the committee and staff, it is an honor for me to be here today speaking with you. My name is Maria Richards, and I am the SMU Geothermal Lab Director. As a geothermal researcher, university program coordinator, and past president of the Geothermal Resources Council, I'll share with you ways to grow our country's ability to find innovative methods which use this nation's geothermal base for a more resilient and diversified electric grid, plus a cleaner environment for generations to come. The House bill is similar to the Senate bill and the Advanced Geothermal Innovation Leadership Act, the AGILE Act, so I'll be referencing that today in my talk. It tells you what is helpful, but does not tell you why it's important. Using my 25 years of geothermal experience, I will provide background on increasing our usage of geothermal resources, building projects connecting industries, and the significance of university research and outreach. The National Renewable Energy Lab's GeoVision study provides a roadmap from today's Western U.S. geothermal power production of 3.6 gigawatts to deployment across our country of 60 gigawatts by 2050. It also estimates 2 million homes are heated and cooled by geothermal heat pumps today, with this number increasing to 28 million homes by 2050. That's 30 years away, yet now is the time to act because geothermal power plants, they take 7 to 10 years from conception to production, and even having enough installers for the geothermal heat pumps and their growth require time for local companies to grow and train employees. And to help create momentum for geothermal heat pumps, please support House Bill 3961, the Renewable Energy Extensions Act of 2019. Surprisingly, it is the oil and gas industry who comprehends the volume of untapped heat and fluid sitting idle, just waiting to be extracted. Oil and gas colleagues share how geothermal energy is considered their safety net because of how giant it is as a resource. We've learned the two industries are definitely different, yet complementary. The SMU Geothermal Lab is known for our outreach and bridge building conferences. These conferences bridge the geothermal industry with oil and gas, waste heat to power, desalination, heat storage, and district energy systems. Plus, we've examined ways to cool inlet temperatures of natural gas plants and how to transition a coal plant to geothermal power. Currently, there are no technologies able to use the 150 to 185 degree low temperature produced fluids from our productive shale plays. The Southwest Research Institute is working with a small company to get to market a technology that could generate electricity from these produced fluids, and it could assist many states. Yet it may not come to fruition. Over the past 15 years, it has been exciting for me to participate as new technologies enter the market, only to learn the company is out of funds before a proper demonstration. The funding of small tech companies in small-scale, low-temperature demonstrations in our sedimentary basins is a strong next step. These are plug-and-play, easy-to-adapt technologies to include if the United States is going to achieve widely sourced geothermal power from sedimentary basins. The House bill and the AGILE Act are funding arriving at a critical juncture for universities. It is a resource assessment allocation for the USGS. Yet, as Dr. Robertson mentioned, universities are important components of this. We have been the lead in collecting and assessing these data for decades. A broader initiative will provide essential funding for keeping faculty and researchers in geothermal exploration while training students. Founding researchers in heat flow and geothermal resources are either already retired or in retirement age. A geothermal fellowship program is another step as part of training the next generation. Funding universities now is of utmost importance to preserve the greater technology transfer and knowledge in keeping us a world leader in the geothermal energy. The DOE's ability to fund universities, national labs, and companies allows all of us to work together in finding innovation, which shifts from the United States as a fossil fuel-dependent country to partnerships between industries, and a win-win-win for the fossil fuel industry, the geothermal and other renewable industries, and the public. Through Congress's consistent yearly funding, the geothermal industry can reach its full potential. Thank you for this opportunity to testify today.
Thank you. And Mr. Cohan.
Chairman Lamb, Ranking Member Weber, and all distinguished members of the subcommittee, I appreciate and thank you for the opportunity to appear before you today. My name is Sander Cohan. I lead innovation efforts for Enel Green Power North America. I am part of a team within the Enel Group to lead the deployment and commercialization of new energy technologies. I'm pleased to provide testimony in support of continued U.S. programs to foster geothermal and water technology R&D. As a longtime advocate for these technologies, Enel's Innovation Group focuses on issues of market deployment, helping new ideas cross the so-called commercialization valley of death. As a company, we are interested in both incremental innovations that can improve existing technologies and disruptive innovations that create entirely new opportunities. What is important to realize that instead of delivering on corporate venture capital, our mission is to serve as a catalyst and driver of energy innovation as an invention's first large industrial partner. The reason why I'm here today is that the programs described in the proposed legislation create the necessary preconditions to realize this mission. Without support from government, national laboratories, and inspiring startups, the full economic and social benefit and impact of geothermal and marine technology would remain out of reach. To give more context, the Enel Group is a multinational energy company and one of the largest integrated electricity and gas operators. Enel Green Power North America, based in Massachusetts, is one of the largest and fastest growing renewable energy companies in the United States. To date, we manage over 100 renewable energy plants in 24 U.S. states with a capacity of just over 5 gigawatts, leveraging wind, solar, hydroelectric, and of course, geothermal and marine. The company is currently the largest wind operator in Kansas and the second largest in Oklahoma. With regard to geothermal and water power, Enel has a history of innovation in both. Italy is a birthplace of geothermal energy, with the development of the first commercial geothermal facility in Larderello, Italy, more than 100 years ago. Today in the U.S., we own and operate 3 binary cycle geothermal plants, the Stillwater and Salt Wells facilities in Nevada and the Cove plant in Utah, part of a global geothermal fleet that spans 4 continents. Enel's experience in water power, specifically ocean energy, is more recent. In the same way Enel manages a competency in geothermal, we also maintain a similar competency in marine energy research and development on both wave and tidal streams. Marine energy is a younger technology than geothermal, and the projects we have are largely in the development phase. Enel Green Power is focused on supporting companies to create and deploy foundational technologies to capture the energy produced by ocean waves. For example, we are one of the lead industrial partners in the Marine Energy Innovation and Research Center in Santiago, Chile. Looking forward, Enel's current innovation slate for geothermal through 2021 contains budget for roughly 15 new projects. This pipeline contains a broad range of technologies, from ways to streamline and improve plant operations, to data analytics and methods to evaluate and process seismic data, to hardware-intensive activities such as new drilling methods and investment in and support of enhanced geothermal systems, such as those being tested at Forge. In the United States, Enel continues to leverage its presence as a geothermal operator to improve the state of technology and increase its economic value. 3 projects highlight our ongoing and future commitment. Our Stillwater triple hybrid plant that contains geothermal, photovoltaic, and solar thermal technologies, our Cove Fort plant that combines hydroelectric and geothermal, and our recent commitment to the University of Utah's Earth and Geosciences Institute. This is a way of saying that continued federal funding in support of research, development, and deployment efforts is important. As Enel and other developers work to expand the footprint of geothermal energy, fundamental investment in scientific capital is essential to overcome substantial challenges. In order to remain competitive with other renewable energy sources and serve as a viable resources, the programs being discussed today in today's hearings are essential. As a developer of technology, Enel's focus would be to expand and deploy these inventions, enhance geothermal systems, minerals recovery, and hybrid systems fostered on the investment made through this policy. Marine energy also deserves attention. The My colleagues and I agree that more work is required, especially in the establishment of open ocean marine. These are key to bridging the gap between smaller scale university and naval sites and the commercial market. In conclusion, successful energy innovations are difficult to realize, especially ones like geothermal and water power technologies that rely on the development of new infrastructure and the construction of capital-intensive hard assets. They require the intense cooperation throughout the entire value chain, originating in fundamental research and development programs like the ones today to initiate the process of technology transfer and continuing through the process of technology deployment and commercialization. My team and the rest of Enel Green Power look forward to cooperate with this network of government programs, national laboratories, and industry in related fields, especially oil and gas, to lower the cost of deployment and realize geothermal and marine's full potential. Thank you again for allowing me this opportunity. My comments today and submitted testimony just begin to address this topic, and I look forward to fielding your questions.
Thank you very much. We'll begin with our first round of questions, and I recognize myself for 5 minutes. Dr. Solan, there's been increasing discussion on our committee all year and back in Western Pennsylvania, where I represent, about emissions from the industrial and heavy manufacturing sectors, sort of apart from the grid itself, and how we start to tackle some of those problems. So I was curious, is DOE's geothermal office looking at this problem at all, and how you could provide heat for sort of very serious heavy manufacturing, whether it's steel or other similar processes?
We are. The Geothermal's office has actually started a program for looking at feasibility of deep direct use for industrial heat processes. So we have a number of studies that represent a number of use cases in a diversity of regions around the U.S. I believe that there's 6 or so, and I think 2 are in the Appalachian Basin. So they're looking at various processes and trying to take a look at innovation in these areas. So whether it's agriculture or a little bit higher temperature processes, but still low temperature for industrial processes in East Texas. We are just finishing those up, and the appropriations committees have taken an interest in doing an eventual demonstration, but we're not quite at demonstration stage yet, so we're also looking at opportunities in more design engineering as a possible next step.
Is there any particular industry or sector or type of manufacturing that would be most promising from the early studies?
That I would have to get back to you on, but I know agriculture, paper drying, these are the types of activities that a number have looked at, especially with the low temperature at this point.
Okay. Are you coordinating with the Advanced Manufacturing Office on any of that, or do you know if they're engaged in this same line of inquiry?
In these activities, I don't believe so. I'd have to get back to you, but we are engaged with the Advanced Manufacturing Office with geothermal on a number of activities, one of which is with AMO and the Critical Materials Institute with opportunities to harvest lithium from geothermal brines. That's an area, and we're also in discussions with them on taking a look at advanced manufacturing for specific geothermal mechanisms and parts, et cetera. So we're taking a look at that as well.
Okay, thanks. Ms. Richards, you highlighted the possibility of retrofitting aging coal plants for geothermal. Is that has that been tried anywhere, or is it more sort of in the idea phase? Could you just kind of elaborate on that a little bit?
Yes. The idea of transitioning a coal plant to geothermal is the ability to do it over a long period of time. So it'd be 5 to 10 years most likely. And the best cases have started to be looked at. Primarily Susan Petty is the person who's spearheading this, and she has looked at, in her team, at ones in Oregon and Washington, and then also in Texas, because of our aging Texas coal plants. And what we have focused on in Texas was the idea that we could overlap with the oil and gas industry and their wells. And the idea is that you would use the same, like they already have water, they have infrastructure, they have, the turbines, they have a workforce. And so the goal would be is to use that same workforce, retrain them, and use the same grids and things like that, and slowly transition from electric power from coal to geothermal being the power source.
Do you know sort of where on the spectrum they are toward a demonstration type activity, or?
Susan has talked with people in Montana as well. So there have been, and there's a coal plant in Oregon that has been specifically been in discussion with her. So those are the two states that have been closest to discussing it. So in terms of the blueprints that would be getting to that point, I would need to go back to her and give you more information.
Great, thanks. And just wanted to ask one question for the group. I don't know if Dr. Solan would be the one or anyone, but I'm curious about hydropower as it gets built onto existing infrastructure. I think a lot of us, given the difficulty of getting infrastructure legislation through, are skeptical about truly large-scale dams in a lot of parts of the country. But in Pittsburgh, for example, on the Allegheny River, the University of Pittsburgh has helped develop adding hydropower capacity to an existing lock and dam that we have on the river. And it's small, but it's going to supply about a quarter of the electricity for the university. Are you aware of other efforts underway to do similar things like this on our existing infrastructure?
Yeah, there's actually about 80,000 unpowered dams that provide a great opportunity. Even if we could do just a small number of those, or a small percentage, it would actually provide a lot in terms of reliability and resiliency. So we are doing activities in these areas. WPTO actually looks at, in a couple areas, low-head hydro, standard modular hydro. So these are the type of areas where if you put in smaller modular, cheaper turbines, and it would make a lot of sense. Because in the past, hydro is an interesting industry because when dams were built a very long time ago, if it was for power, folks just optimized it to deliver as much energy as possible, and then they thought about the environment after that. Now that we're looking at in-stream reaches and low head, we're actually trying to design it as an integrated function across all the needs that you need to meet. And instead of making it unique to one situation in one spot, as we did many years ago to get that last kilowatt hour out of every project, for the most part, a standard modular design would work many different places and would actually bring the cost down a lot. So we expend a lot of activities in that particular area.
Great, thank you. I'm out of time. I'll recognize Mr. Weber for 5 minutes.
Well, where do we start? Thank you. I'm going to go back to you, Deputy Assistant Secretary Solan, for a minute. As you mentioned in your prepared remarks, the future of the electric power grid may look very different than it does today. Do I recall correctly there are 9 grids in this country, electric grids? Do you know that number?
I don't. It depends on how you define it, whether it's reliability or organization area or interconnections. But there's a lot of different market structures, and whether it's regional transmission organizations.
I'm thinking there's 9 grids, and of course Texas has ERCOT, Electric Reliability Council of Texas,
Correct,
which is about 85% of the states in its own grid. So you say that it's going to look very different. However, no matter how those grids evolve, we understand that many of today's challenges will still be there in the future, meaning we will still need to address grid flexibility. You said connectability, how you define a grid, and I would add variability, while we want to ensure the reliability and the affordability of energy resources. So as we seek to decarbonize the electric power sector, we will need to advance a diversity of clean energy resources in order to encourage the development of innovative energy technology while ensuring at the same time, minimal cost increases for American consumers. You follow me? Okay, I'm getting to my question. As the Deputy Assistant Secretary for the Office of Renewable Power, how do you propose to balance all of these? First, we have to define those grids. How do you balance those affordability, reliability, all at the same time?
So Assistant Secretary Simmons has made one of his 3 core pillars on affordability. So everything that we do is trying to bring the cost down and the efficiency. I mentioned the GMI before. This is one of the efforts that we're doing to make sure that the grid is both reliable, resilient, and that we're bringing costs down and make it more affordable as we move forward. But the grid is definitely transitioning over time, and how we use electricity. The system's becoming, the need for flexibility and speed is a lot greater than it used to be.
Absolutely increasing. How often do you coordinate with the Advanced Research Projects Agency, Energy ARPAE, in your work with the Geothermal Technologies Office and the Water Power Technologies Office? Do you get to coordinate with them?
Yes, we do. Actually, for each area, the RPE has actually had some calls related to enhanced geothermal systems with the input of the geothermal office to make sure that the space that they were in was complementary to the work that we were doing. And all of our applied research offices in renewable power actually work directly with RPE on those, and in many cases, we actually sit on each other's panels.
And the Office of Science as well?
The Office of Science, we do a lot on the storage area, which it does include hydro. We do it a lot in ERE generally to do with battery chemistries. So that's not only in renewable power, but that's also in the Vehicle Technologies Office as well. But we also work on that with grid storage. So that's Assistant Secretary Simmons' second pillar is on storage.
Okay. I'm going to jump over to you, Dr. Moore. In your prepared testimony, you highlight the various conditions of your research site that make it ideal location for DOE's first Forge field laboratory. So how unique are these conditions, number one? And the second question, in your opinion, how important is it for this kind of experimental geothermal facility to represent general geologic conditions across the entire country?
Thank you. The DOE established, I think,
We'll
five.
move closer to your mic, please.
The DOE established 5 criteria for an ideal enhanced geothermal system. One was temperatures of 175 to 225 degrees at 1.5 to 4 kilometers. The second was the rock type should be granite. Third was no environmental issues. Fourth was low seismicity, and no connection to an existing system, so a greenfield system. We looked at sites across the country, and Utah is not unique. Granite is the country rock. Here's an example of one what might look like, and a permeable fracture in it. Granite is found across the country. In fact, I would suggest that we could drill here beneath our feet to find conditions that are similar. Probably drill a little deeper, but we would find very similar conditions here.
Mr. Chairman, I have about 17 more questions, but I guess I better yield back. Thank you.
And only 15 more seconds.
I know.
which is the shame. Now, recognize Mr. McNerney for 5 minutes.
Well, thank the Chairman. I thank the witnesses. I really liked your testimony. It's encouraging. It's positive. Thank you for that. Dr. Robertson, you mentioned a capacity for potential for 4,300 terawatt hours. That's per year, right?
Yes, that's correct.
And how much of that is marine power?
All of those would sit within the sort of broader space of marine power. Wave would account for about 80% of that. The numbers were, if I can bring them back up.
Well, look, I was kind of driving at a question. How much impact would that have on the coast if you took that much energy out of the waves and the
Oh goodness,
tides?
this is like a bulk resource. It's not feasible to block the whole coastline to generate that much electricity. So it's really about finding locations where you understand the implications of the other economic activities that are happening in that location in the state of Oregon, and the test facility we are building there with Oregon State University. We've had extensive engagement with the crab fishery, the Dungeness crab fishery. So you have to account for these. It's a large marine spatial planning exercise to try and identify high priority locations and use those as your first deployment sites.
Thank you. Dr. Moore, talking about injection and production at geothermal, how about the wastewater? How does the wastewater production from a geothermal compare with the wastewater production from fracking, for example?
These are completely 2 different processes. In a fracking environment, water is produced along with oil and gas, and that water has to be removed, can't be reproduced. So in the oil and gas industry, that water is taken somewhere else and injected into rocks that are already saturated with water. And occasionally, some of those fractures in the basement will slip and we have earthquakes. Geothermal doesn't have wastewater. We inject and we produce. So in a natural geothermal system, the water is already present in fractures like these. That water is produced and then is re-injected back into the reservoir. In fact, by law, it
So
must.
you reuse the water?
Oh,
the
yes,
waste, the
yes,
production
it's
water. Okay.
renewable in that
All right,
sense.
thank you. Ms. Richards, what about some of the extra benefits of this wastewater? For example, in Southern California, there's efforts to couple geothermal with critical mineral production.
Yes, in fact, the lithium industry, there's a company from Australia who is working on the largest geothermal power plant that will exist in the United States just to extract lithium. So there's a lot of production there. The wastewater, though, also in our sedimentary basins, has a huge opportunity for us to gather heat and create small distributed energy systems as well as larger EGS systems. So even in the central United States, this wastewater has opportunity to be productive.
Okay, thank you. What about the role geothermal plays in baseload and providing additional grid storage? What are some of the benefits of that part of geothermal energy?
So with storage, and solar makes a lot of heat, and so, but if it's at night, it gets cool. So the goal is to take that hot solar fluid, solar can heat fluid, that fluid is then put into wells, such as abandoned oil and gas wells. Those wells then become a storage which contains that heat that then is brought back to the surface and then is used during the day for the needs for the grid or to offset the solar.
Okay, Dr. Robertson, you highlighted in your testimony the need to educate and train the next generation of energy technicians and engineers, and so I couldn't agree more. What role can our universities play to enhance that situation, to improve that situation?
Thank you for that question. That is the fundamental role of the universities and the colleges and our training programs across the country to do that. You know, we facilitate the workforce that goes into our fantastic national labs and into the governments and into our private companies. And it is our role to take young, raw talent, educate them, teach them to be innovators in that space, and then put them into these different companies or institutions. And in the marine energy space, there is no lack of interest in those new recruits. Fundamentally, our issue generally is funding to do the research and the training to put them through so they can do it. So we can put them into the labs, put them into companies, and put them into government.
So federal grants and so on are very important in that process.
Exceptionally important, both the grants and the vision associated with them, so that we can make sure we attract and maintain the best faculty members within the universities to focus their research enterprise in this space, so that they aren't attracted by something else where there is research and investment. So,
Thank the chairman for your indulgence.
And recognize Mr. Baird for 5 minutes.
Thank you, Chairman Lamb and Ranking Member Weber, and I want to thank all the witnesses for being here today and sharing your knowledge with this committee, because we're in a constant search for reliable, cost-effective sources of energy. So I'm going to start with Ms. Richards. In your prepared remarks, you described how expanded geothermal energy generation could benefit rural communities and ease the pressure placed on cooperative electric facilities. District 1 that I represent in Indiana's 4th Congressional District is largely rural. So could you expand on how increased geothermal energy generation could benefit these rural districts and our rural cooperatives?
Yes. Geothermal, because it's everywhere, as Joe said, it's right below us even, right here, has the ability to build small or large, depending on the high temperature or low temperature resource that is there, but then to either build electricity or offset the need for electricity through something as basic as a geothermal heat pump for a home or a building or a school. But it also has the ability to then stabilize the grid with distributed and with the storage of, like we talked about earlier. And so it's the idea that through, especially sedimentary basins, and being in Illinois, there's a sedimentary basin there that could be tapped into for a distributed system.
So would any of the other witnesses care to comment on that question about the impact in rural areas?
I couldn't speak to the geothermal aspect of that question, but I think it's important to highlight the multitude of scales that both these technologies can work at, whether you're using a heat pump for a single community or whether you're developing a large-scale facility to power an electric grid. I think the same opportunities exist on the water power technology side. The DOE has funded a fantastic project to put an in-stream hydrokinetic turbine in Igiugig, Alaska, to provide power to a community that's pretty much inaccessible most of the winter, and 100% reliant on diesel generation. And these are the sorts of technologies that you can create at smaller scale and deploy for rural and remote communities. Additionally, it's not just coastal communities that also get to benefit from this, so also communities that are landlocked through technology innovation.
So where there's current expression and obvious resources for geothermal, for conventional hydrothermal systems, these tend to be in pretty rural areas. These provide important jobs for specific areas, whether it's in parts of Wyoming or Utah or Idaho, like Raft River, or Neal Hot Springs in eastern Oregon. And these tend to be communities where it's an important employer. And also, it's an innovative technology, so it does attract talent also from outside the region.
May I follow on with a comment? Forge, Utah, in fact, is located near a community of 1,400 people. We employ the local residents. We employ the students at the local high school. They're excited about renewables. They take that information to their parents. We provide jobs for the neighboring towns. So it's an important resource. And heat pumps, in terms of rural communities, heat pumps are not geologic specific. And so they can be used anywhere. And they are being used. Electric and direct use require population centers, but with enhanced geothermal systems, I think that's a viable alternative for rural communities as well.
Thank you very much. I yield back the rest of my time.
Thank you. And Mr. Foster for 5 minutes.
Thank you, Mr. Chairman, and thank you to our witnesses. As we put more renewables on the grid, that obviously makes a bigger premium on energy storage, which is something I've been worried about a lot. I'm proud to have introduced what's called the Better Energy Storage Technology Act, which now has 38 bipartisan co-sponsors. It would reauthorize and reorient the DOE's grid-scale storage research, development, and demonstration efforts around ambitious technology goals to facilitate breakthroughs. And the BEST Act directs the Secretary of Energy to establish moonshot goals of up to 5 demonstrations of grid-scale energy storage that will meet aggressive commercialization targets for cost, performance, and durability. And so I have several questions about that. First, could you elaborate on how you see the horse race between the different things like pumped hydro and so on, and how they are going to compete against the rapidly falling prices of batteries, for example, and where you think that's going? Dr. Solan?
So right now, the hydro actually accounts for, in pump storage, 95% of our actual storage for the
Currently
grid,
the
which
winner,
a lot
right.
of people don't know, but it's kind of taken for granted. It's also a great example, thinking about how pump storage operates, how the grid's changing, because it used to be you'd pump the water at night when rates are low and there wasn't much demand, and then as load ramped up during the day and there was a peak, you'd let the water down and you'd produce some power. Now things are changing, actually. So we have a couple studies that WPTO is working on with Argonne National Laboratory to take a look at some of these issues. And the preliminary results are actually showing from actual pump storage facilities that that's not the way that they're necessarily operating anymore. So for example, in California, where there's a lot of solar and there's a lot of generation at certain points in the day, it turns out that for arbitrage, and because there's and based on the rates, that they might actually pump up during the day, and then have like a sort of a head and shoulders pattern where as solar comes down, then you start letting the hydro out. So it's actually illustrating how the grid is changing as we get more variable resources with that. A lot of companies are looking at grid scale storage in the near term with lithium ion. It depends on what their targets are, as you were saying. If you set goals for different, say, durations of power or different materials. So DOE Office of Electricity is actually looking at batteries that are for grid scale, but don't necessarily use.
Yeah, well, the legislation we've introduced is deliberately technology neutral. I was just wondering how it was likely to end up. And yeah, Ms. Richard, you mentioned the idea of just pushing the heat back in the ground, and maybe even cycling that, which is a concept I wasn't familiar with. It'd be interesting. I presume that does not ramp on and off very rapidly, or does it?
It could be done daily.
Daily, yeah,
Right.
but not when a cloud goes over the solar array. It's not going to respond in that time scale.
I would agree with that.
I would assume.
Yes.
But, so it may well be that optimized storage will have a mixture of many technologies. I was just, our pumped hydro is that essentially a mature technology? That turbines have been designed by geniuses back in the 1930s? not
There
improved
actually
upon?
are some new types of designs that are coming out, but a lot of this was built a long time ago. And one thing that we're discovering on the innovation side, that it's not necessarily on the actual power production side, the Water Power Office sponsored a FAST prize to commission pump storage hydro faster. And a couple of the winners recently, they were actually tunneling and construction companies who said, this is not the way we would do things today. We could reduce the costs with these technologies that we've been developing for different types of industries. So that's where some of the innovation is going to come.
Underground reservoir is the whole point.
Yeah, and closed loop.
Potentially on flat areas like the Illinois 11th District.
Yeah, and there's some innovative subsurface. There's closed loop, which is not connected to natural hydro systems.
Dr. Moore, when I recall last looking at enhanced geothermal, there were problems that were the development of hydraulic shorts between the injection and production wells, induced seismicity, corrosion of the produced water, causing lifetime problems, and then just the difficulty of dumping the heat. You obviously need a nearby river or some sort of, you need a source of cold as well as a source of heat to get your Carnot engine. What's the status of those?
We can take them one by one in terms of the thermodynamics. That's been resolved. We can use single flash, double flash, multiple turbine systems for electric
Okay,
generation.
I was referring to, you have a production injection and an extraction well, and that you'll get one channel carrying all the burden, and you won't really extract heat from the whole rock mass.
That's a potential problem or a challenge in any geothermal system. We're looking at Utah Forge in a different way. Most of in fact, all of the EGS projects prior to this have looked at large sections of open hole and tried to fracture those large sections. And in that case, you will tend to get a single fracture that controls fluid flow. We're actually taking a step back and using oil and gas technology. So at the Forge site, we'll be casing the well and then using isolation equipment to isolate small sections of the well, stimulate those sections behind casing. In fact, we had the first test in April. It was very successful. So this is a mechanism to avoid that short circuiting.
Okay, and Mr. Chair, could I have another 30 seconds?
Yep.
All right, yeah, so the corrosion for the rock types you're looking at, is that a solid?
Corrosion is not an issue in geothermal systems. It tends to be a problem in the Salton Sea where the solid contents are 300 plus and the fluids are acid. In most geothermal systems, fluids are benign and corrosion is not an issue.
Okay, and then finally, the location, do you need a river nearby to dump the heat, or what is the cold source?
No, you can't dump the heat. This is a recirculating system, and so the fluid that comes through the turbine.
But you need a Carnot engine from going from hot to cold,
yeah,
and
so Sorry.
Actually, what I'm understanding is in our binary technology systems, that those systems have a hot and cold side. And so the hot fluids coming out of the earth go back down in and get reinjected. But in order for the binary surface part to be able to have that Carnot difference, you have the cold source, which is either air-cooled, or that's where the river comes in, or the idea of some sort of water source at the surface that is a cold, to create a difference in temperature.
Right, okay.
But not at a large power plant.
And I
It's
may
large-
just have to stop you there so we can recognize Ms. Bonamici, and
Yes.
thank you for your patience.
Thank you very much, Mr. Chairman and Ranking Member, for allowing me to participate as a full committee member, but not a member of the subcommittee. I'm so glad I'm here today. This is a great discussion. Thank you to the witnesses. The ocean covers more than 70% of the surface of our planet, and we know that the waves and currents and tides can be used as a plentiful renewable resource. And as we transition to a clean energy economy, we need to recognize that potential of marine energy. According to the U.S. Department of Energy, there's enough kinetic energy in waves and tides along the U.S. coastlines to meet a significant part of our nation's power. And Dr. Robertson, thank you for clarifying that in your testimony, reinforcing that. Oregon is at the front of marine energy. Thank you for recognizing that with Dr. Robertson, you being here today. And it's in large part because of the leadership of Oregon State University, the Pacific Marine Energy Center, and pioneering businesses like Vigor. One of our great shipbuilders in Portland. Last month, I had a chance to see the ocean energy device Vigor built in collaboration with the Marine Energy Center before it got tugged off into the Columbia River and it's on its way to the coast of Hawaii. It wasn't until I was actually standing in front of it and actually got to climb onto it and explore it that I understood and grasped the scale of this resource, but also the potential. Importantly, we can recognize that efforts to extract power from moving water can be done without jeopardizing the integrity of marine environments. And I know from representing the north coast of Oregon, we can get that done. We know the potential of marine energy, and federal investment can help unlock it. I'm continuing to lead my colleagues in advocating for robust funding for the Department of Energy's Water Power Technologies Office. This funding supports the leading research and development efforts at the Pacific Marine Energy Center, but will also help efforts to establish a wave energy test facility off the coast of Oregon. I'm also pleased to be co-leading the Marine Energy Research and Development Act with Congressman Deutsch from Florida. Our bill will accelerate the introduction of marine energy production in the United States. So, Dr. Robertson, you mentioned in your testimony, you talked about how the development of marine energy technologies is a challenge. So can you talk about the current barriers for the demonstration of technologies and how Congress can better support these efforts to make sure that marine energy doesn't fall within that commercialization valley of death? We want it to be deployed at scale.
Thank you very much for the question. I think there's a host of ways that through supportive funding and through collaborative efforts between the national labs, the universities, and industry, we're looking at these questions of how do we avoid the valley of death and how do we get at some of the hurdles. So firstly, working in the ocean is just more expensive. You need to use vessels, you need to wait for the waves to die down, you need to be able to access the ocean. It's a lot more expensive than having a pickup truck and driving out into a field and testing a wind turbine. It just takes longer. There are seasonal effects as well. Off the coast of Oregon, there is about 6 months of the year where we would not be able to access it. So it does take longer to do this innovation, but we are achieving significant successes, the ocean energy buoy on its way to Hawaii being one of those examples. The development of the PacWave test facility off the coast of Oregon is a significant step in that direction. It provides a baseline on the environmental impacts of marine energy. It provides a final demonstration site for U.S. technology developers to prove out their products before selling them into the domestic market and internationally. It allows us to compete with our European partners who are also active in that space. So it's a big part of the effort as we go along. The other thing, I think one of the biggest hurdles we continue to face in this space is going through the environmental permitting process. But there are opportunities of great collaboration. In that realm, I've got to acknowledge the efforts of Dr. Andrea Kopping at PNNL at the Pacific Northwest National Lab, who writes for the International Energy Association's Ocean Energy Systems Report, State of the Science. Where are we in this space so that we can start to work with regulators to accelerate the development?
I'm going to try to get another question in the
Sorry.
remaining time. No,
Yeah.
that's okay. I want to really focus on how Congress can better support the development, but I appreciate that you talked about the holistic view of the development pathway. So what are the advantages of partnerships? And based on your understanding of the Water Power Research and Development Act discussion draft, are there additional resources that the centers would need to thrive and compete with other energy sources?
Yes. I think we have a great collaborative model with the marine energy centers representing the academic institutions, with the national labs being actively involved, with the industry being part of the sector. It's very collaborative. This isn't a competitive industry. This is one where we all identify collaboration is the only way for us to move forward. I see one of the hurdles right now, and as my previous comment said, was training the workforce to enter these national labs, enter these industries so they can continue to thrive. We need to make sure that the smartest, the brightest people end up in this space and drive the innovation pathway and do it quickly. So it's the combination of the training to get the people into the industries and providing the infrastructure to allow them to test quicker, test cheaper, and test more rapidly.
Terrific. As a member of the Education and Labor Committee, we're working on that as well from that perspective. Thank you again, Mr. Chairman and Ranking Member. I yield back.
Thank you very much. Mr. Cohan, in your testimony, you talked a little bit about the role that you all play in investing technologies that have not been proven to work as a first-of-a-kind demonstration, but don't yet have the capital infrastructure to move beyond that. So I was kind of hoping you could maybe elaborate for us a little bit your theory of where the government is best involved here and where it's not, particularly as you get closer toward demonstration scale. What's the balance between government and private sector involvement? Where have you seen us work well together? Where do you think we should be doing more or just doing better?
I think that there are opportunities all across the value chain. I think when we think about the commercialization valley of death and sort of the barriers to commercialization, or the predecessor with the technology valley of death, it's actually a series of mini valleys. There's a series of pitfalls all the way down and all the way back up that I think would benefit from support from government services. I'm glad we're discussing Vigor and the ocean energy devices. I think they make a good example. Principally, I think there's a number of ways. One is, I think in terms of supporting programs for partnerships between large industrials and startups, government has a larger and broader view. But I think more importantly, government has a way of supporting the groundwork for these things to happen. So not just the development of technology, but the development of infrastructure around these technologies, the creation of, for example, in the marine energy business, onshore heavy industry to build the infrastructure to build offshore devices. I think this is really important from an education standpoint. I think it's important from a skills standpoint, and it's important from a technology and infrastructure. The ocean energy device, for example, is enormous. You can't build that every day, and you can't build that in your backyard. And so support for, and then support for that can come from any number of ways, from, the loan guarantee program to specific challenges and programs to focus and develop industries around technological advancement.
Do you think loan guarantees have proven to be an effective method for enlarging some of these projects?
They are a method, I would say. I would say that, the idea here is not to specifically mandate a technology, because I think there are different needs in different ways, and it's very hard for anybody to see in the future. But I think the role here is to create the bandwidth and the environment and the space for industries and national laboratories and startups to work together. And so that can be, everything as light as I said, a water power challenge, but it can also be specific programs to drive partnerships into a marketplace or create a marketplace in industry.
Thank you. That's very consistent with what we've heard many times this year. And with that, I yield to Mr. Weber for 5 minutes.
I thank the chairman. Gosh, 5 minutes is never going to get it, but we'll start. To all the witnesses, when it comes to advancements in water and geothermal power technologies, how important, or have you considered, is it important, the role of international collaboration? First question. If so, who are our main international collaborators in this space? And thirdly, who are our competitors? Dr. Solan, I'll start with you.
That's a great question. In terms of geothermal, we've actually been very active in working with New Zealand. New Zealand's been helpful in supplying data for us to actually do some machine learning AI type projects. So we have an agreement with them. But the geothermal office is also working directly through Geothermica, which is working with the EU and essentially leveraging both resources to provide some shared projects. So we've actually been working with them, and they've been.
So it's
they've been
important
pursuing
we've
that.
got the collaboration with those. Who are our competitors?
From what I understand, of course, China is pursuing all areas of energy.
Well, I'm sure they're going to convert their coal plants to geothermal.
I did want to mention, though, also on the water power side, they're very involved internationally, and we're actually hosting, for the first time ever in the U.S., the international conference next year related to marine and ocean energy. And that's a great opportunity for the U.S. to show leadership.
Let me jump over to Dr. Robertson. Important? Is it important international collaboration?
Without a doubt. It's key. You know, we need to leverage every dollar in every part of the world to facilitate the development of this industry. And there are huge lessons learned that can be done that. So over the past year, I've traveled to our main competitors, which competitors and collaborators would be Canada, the EU, and Australia. There are other countries who are spending significant dollars in this place, in this space. I would say the U.S. plays a leadership role through the Water Power Technologies Office, understanding that we need to open the aperture of what we consider marine energy to do.
So I need to move on. Dr. Moore, is it important?
It's critical, especially in this enhanced geothermal environment. These are extremely expensive experiments, and we need to leverage what we can. We right now are working closely with China, who has their own EGS experiment.
Are you afraid they will steal our technology?
There's no technology to steal here. We need to learn how to do this.
We already know how to do all this.
I wish we did.
Okay. That's what I'm afraid they're stealing from us. Ms. Richards, how about you? Is it important?
Yes, in terms of China, they're the ones who've developed the first oil and gas field into geothermal.
Okay.
So they did it before Texas.
Well, we need to steal that. I mean, we need to talk to them about that technology.
Exactly.
Mr. Cohan.
Well, I think international collaboration is critical, but that's because I'm biased because my job is 100% about international collaboration.
Okay.
I'm the link between our U.S. and Italian operations.
Yeah.
You know, I thinking about, you know, collaboration versus competition, there are more projects than money or people right now. And so, you know, there's only outside and there's only collaborative outside. The reason why we're operating in Chile is because there's a positive effort from the Chilean government to build a marine energy business there.
I need to move on if I may. So let me talk about the wave energy that you talked about. Any thought, and I'm from a coastal area. I have the first 3 coastal counties of Texas, starting at Louisiana, that other foreign country, and then going down southwest. So is there any thought to when you have that kind of a structure and you harness the power of waves, does it reduce the amount of erosion on that beach? Has that been looked at? Do you know?
I don't have any specific expertise in that area, but I can find out for you.
Okay, one would assume that if you harness the power of the waves and slow them down, now the surfers might complain about that, right? They have to get out in front of that barrier to do the surfing. But that's something interesting if you can get back to that.
Well, I suppose to that end, I suppose it depends on the technology. It depends on how far out in the ocean you're talking about.
Sure.
So, you know, with a lot of wave energy technology that we develop, we're pretty far out there.
Well, so what's the distance? You're going to have the infrastructure, the transmission lines, as it were, albeit buried, you know, beneath the waves on the ocean floor. How deep's the ocean floor? How big is the line? What's the mileage? What's the furthest out you all have contemplated going?
We haven't gone too far out. As I said, these technologies are sort of in early stages, but you're talking about in the hundreds of meters to kilometers.
Okay.
So, you know, when you're talking about the Gulf, you know, we have offshore rigs that are at those
We're going 20 miles to 40 miles out
Right.
with oil export terminals.
And you could piggyback on that infrastructure. I mean,
That's the point.
Yeah.
Sure, you betcha. Mr. McNerney and Mr. Robertson, Dr. Robertson had that was about the beach erosion. jumping back, Ms. Richards, you talked about injecting the fluid that it was hot, you didn't need it, you could, you brought it and you injected it at night and you brought it back during the day. You remember that?
Yes, I did.
Okay.
Right.
You're going to lose temperature at some point. You're going to have a temperature drop. Have we calculated how much of a heat loss we have at that point?
So there are people who have worked on that, and I can get back with you in more detail.
Okay. And then finally, Mr. Robertson, Alaska community, and you're talking about with Congressman Barrett about a community in Alaska that had potential project. Well, what's the population of that community?
I don't know the number off the top of my head, but it's less than 100.
Less than 100. I would say that's a fairly small-scale plan.
Without a doubt.
Yeah. And you said they do diesel power. Are you aware of Newfoundland that I was there about 10 years ago, give or take, and they use a lot of diesel power. Do you know if they still do?
Newfoundland?
Uh-huh.
They do, and they've got their large-scale hydro system that they're also building. But it's part of the value of these small communities is that we can build economies of scale and we can build small prototypes that are cheaper.
Okay. All right. Well, I don't want to keep everybody. Thank you, Mr. Chairman.
Thank you. And Mr. Foster for an additional 5 minutes.
Thank you, Mr. Chairman. Let's see, Mr. Cohan, could you say a little bit about collaborations with national labs and how you see this fitting into things? Solan, I'm sorry.
Yeah, we work directly with the national labs in all of our programs. So we utilize the universities, we utilize the national labs. It depends on the program, which specific ones that they work with, but national laboratories are foundation of knowledge as far as and doing certain work that is mission-driven based on our programs, and they also work directly with businesses.
Is the handling of the intellectual property, which we've sort of touched on, is there a clearly understood national goal? Well, I sort of view the decarbonizing the world economy as two problems. One, the U.S., we have enough money in this country to decarbonize our own economy. But unless we can develop cheap technologies, that's not going to be enough for, India, South America, other places with less money. So we have to work on knocking down the cost of these things. And part of that is that we can't, we're not doing this entirely as a profit-making enterprise for the United States. We have to understand we're providing technologies that will be used worldwide. And I guess, Mr. Cohan, what is your sort of attitude about the worldwide goals in this? Are there a bunch of for-profit entities that are trying to go and dominate the market here, or are they really trying to all solve the problem with whatever technology ends up working?
We see this mission as part of, we see them as one and the same, frankly. We see corporate sustainability as part of it, as part of environmental sustainability. So we've made a very specific decision as a company to pursue clean energy as a means of maintaining ourselves as an entity going forward. And so, our core mission is an idea of open power, the idea that as we create things that benefit the communities we operate in, we too survive as a corporation.
Yes, Ms. Richards?
I'd like to point out that many of the small technologies for turbines have come through the United States that are companies that haven't succeeded. And now one of the companies that is pushing forward is a company called Clamion, who's out of Norway or Sweden, up in that part of the world, and coming in and is like the new exciting one that people are also looking at. And that's a case where we are losing out because it is needed technology around the world. And if we could support these small companies, we would have a technology to export.
Okay, so there's still a problem with tech transfer in this. That there's a long list of things that were developed at U.S. labs and commercialized offshore, including many money-losing enterprises offshore.
Can I add something on tech transfer? When we partner with startups and when we partner with national labs, we have very clear delineation between IP that we create mutually and IP that the startup brings to the community. And we try to focus as a company on our core mission, which is producing reliable electrons and valuable electrons. And so our goal is to support the development of this R&D and to support this development of intellectual property. And so, if we were to second it, it would get in the way of our actual mission.
Now, someone who may have been Dr. Solan mentioned salinity gradients as a source of potential power. What's the status of that? And are there near-term projects? Or Dr. Robertson, it's yours. You can also, your testimony also mentioned charging stations for underwater things. Is there a bunch of military money going into that for drone swarms and stuff? If you just give a quick update on those two things.
So on the first one, I would have to get back to you on. I'm not firmly aware of the current status of ocean thermal and ocean salinity. On the second run, the UUV underwater vehicle recharge. Yes, there's definitely military interest in that space, but there's also great oceanographic interest too. We don't understand the ocean yet. That is purely due to the fact that we can't provide reliable power to sensors in the deep ocean, and we need to be able to overcome that barrier. We have the sensors, but we can't power them. So marine energy provides an opportunity for us to be able to power those sensors so we can understand the ocean. We also have military applications that those would provide huge benefit to.
You did mention, we did mention in testimony, thermal conversion. In terms of the priorities of the WPTO, we spend the most, in terms of marine energy, on wave energy, because that's our biggest resource, and probably thermal conversion is probably an area where we provide the least, just because of the opportunities and where our budgetary priorities are.
All right. Thank you, and yield back.
Okay, thank you again to all the witnesses for joining us. This was a tremendously helpful hearing as we get ready to finalize this legislation. Just a reminder, the record will remain open for 2 weeks for any additional statements from members and for any additional questions the committee may have for the witnesses. With that, the hearing is now adjourned.